Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer, sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Complete Developer Podcast, going down the Wikipedia wormhole so you don't have to. Logic programming is a paradigm that is based on formal or mathematical logic. Apps written in logical languages are basically sets of commands in logical form. They express facts and rules about a problem within the domain. We're going to discuss the basic concepts behind logical programming and how algorithms are formed in logical languages. Then finally, we'll compare logical programming with functional programming, going over some of the pros and cons of each. But before we get started, Will, what have you been fighting this week?
Well, I got a haircut, so like the long beard and the hair is gone. The hair is going to be on some poor kid's head, and they're going to make the wig and all that stuff. I donated it, basically.
And the beard is going to be for some poor guy who can't grow his own.
Right. Or somebody's armpit hair or whatever. No, actually, they just kind of tossed that. There was a lot more gray in it than I thought. I was surprised by the amount, because I guess the front of it was more not gray than everything underneath was.
So I got to say, the last time you got your haircut did not look well. They did a bad job. I'm just going to be honest with you. I don't
Somebody couldn't control the weed eater.
Yeah, I don't know exactly where you got it done. This one looks awesome, dude. Like, you look like a professional and an adult male. Your previous haircut looked like your mom had done it when you were 5.
With a bottle of wine.
Yeah.
Yeah. Well, and of course, I had the goatee, right? Because they trimmed the beard down and I had the goatee. And then I realized I looked like Tim Curry. That wasn't really my jam. So I went ahead and shaved that off too. I'm very, very cold all the time right now. I'm assuming that it will get better.
I'm really trying not to call you Dr. Frankenfurter.
Okay.
Rocky Horror, man.
Yeah. So how about you?
Well, it is the end of the sprint, and we're at crunch time trying to get everything tested before our deadlines. It's not that we took on too much this time, but we did have one story with kind of a fun challenge. I even created a developer launchpad challenge from that story. Also, we made some changes to the data model, so that takes time to get it in all the places, from the database to the API to the UI. And so our QA didn't get started as early as I think they would have liked to. But it's crunch time. It's always crunch time at the end of a sprint, just to get everything out and working and tested. Speaking of working, I've been working on my presentation for Music City Tech. This episode airs 1 week before the conference, and so I'm hoping to have it all finalized and practiced several times by then. I'll probably come over here and give it to you so that you can be like, "You suck, don't do that," or whatever. I've been speaking with...
Do I even have to review it before I do that? Or
Yes, you have to hear the speech before you say it sucks.
Oh, okay. Well, that's not according to Facebook rules.
We're not in Facebook anymore.
Yeah, Toto, we're not in Facebook anymore.
I've also been talking with Gaines about the panel that we're going to be doing. He suggested that we could even do a live feed of it while we're there. So we're going to have to figure that out, if this is possible and feasible to get set up between now and the conference. So it's kind of a neat idea that he had. I'm hoping we can make that work. Speaking of live feeds and streaming, I have an interesting product to help with that for IoTs. So this product is called Sling Studio Hub. While it's a little bit on the expensive side for the hobbyist, this is a way to connect all of your cameras, smartphones, and other recording devices to a central hub and switch wirelessly. It creates a secure HD video quality hotspot for your devices so that you can switch camera angles while recording or broadcasting. For streamers, this hub supports Facebook, YouTube, Twitch, Periscope, Restream, like all the things that we use, plus some, and also records the feed. You're able to control the feed wirelessly through an app on your phone or tablet, or you can plug it into a computer and you have a little bit more control. You can have up to 10 source devices connected to it, with 4 monitored sources if you're connected into it and 2 monitored through the app. So it's really neat. If your camera isn't Wi-Fi enabled, you can get a camera link that will add Wi-Fi capability to just about any camera. So it's really cool. I'll have a link to it in the show notes. Who's talking to us this week?
Well, this week we grabbed an email from Ryan Trotter. It says, I've just started listening to the podcast and fell in love with it. My question is, how can you progress learning from practicing concepts to building fully fledged applications? Thanks. We've answered similar questions before on Facebook Live. Honestly, the best way to do it is to go build something. Find something you want to do and just build it. That's the shortest path, right? Because then you have an application and you're building applications, like you're there. All the weird quirks and stuff that you run into that aren't in the examples and learning how to learn and how to dig up the information you need, you're going to get that in spades.
Oh, yeah. Like, one of the first things that I did was build the website for this podcast. Like, that was the first full-fledged app that I built. It was, we need a website for the podcast. So I went in and worked on it. It was mostly the front-end stuff. Yeah. We were using WordPress. But that gave me a place to start. And then I found a really great tutorial when I wanted to learn some more, like in Hibernate and a few other things on how to build a blog. So I built one for my sister. She hasn't used it yet, but I did build her one. And so I had a goal in mind.
Right.
And I followed the tutorial, and then I added a little bit here and there to it to build something, even if it is just, reinventing the wheel. You're not doing it to really solve a new problem. Just solving the problem for yourself or pick something that you want to create will help you learn that.
Yeah, and I think this is kind of like learning a foreign language. For a little while, you've got to pick up the basics and get to the point where you can have a conversation. Mm-hmm. And then you go and you learn by talking to people in that language. This is sort of the same thing. You're engaging with the process of building an app now that you've got the basic vocabulary.
Oh, yeah. My Spanish got a lot better when I went down and spent some time in Mexico.
Yeah.
It's terrible now because that was a long time ago, and I really haven't kept up with it. But I could hold a conversation, a very basic, rudimentary conversation.
Yeah.
But I could hold a conversation when I was down there, and that was awesome. I couldn't do that before I went down there. I knew some of the fundamentals, but I couldn't hold a conversation.
Yeah, that trial by fire really helps a lot.
It really does. So thanks, Ryan. We really appreciate good questions like that. Send us another email with your contact information, because we've got a Complete Developer water bottle just for you. Guys, I am ordering some new water bottles. So if you've emailed us but haven't received yours yet, don't worry. It will be on its way soon, and I'm probably going to throw in a couple of extra things just for you guys that had to wait. If you'd like your very own Complete Developer water bottle, leave us a review in iTunes or comment on the website or any of our social media. We post all our episodes to Facebook, Twitter, LinkedIn, and Google+. We're also on Instagram, Path, and Tumblr. And check us out each week on Facebook, Twitter, and YouTube Live, where we talk about what's going on in the tech world and answer some listener questions. Join the conversation anytime via Slack by going to slack.completedevelopernetwork.com.
So it's finally here. We've been waiting since last year for Music City Tech, and we're 1 week away.
Have you ever wondered what it's like to record a podcast? Sit in the audience as we host a panel at the conference that will later, through the magic of editing, become an episode. Meet us and the Junior Developer Toolbox crew at our booth and get some of that really awesome Complete Developer swag.
Music City Tech is a 3-day event from May 31st to June 2nd, consisting of simultaneous conferences, Music City Code, Music City Agile, and Music City Data, each focused on a particular community of technology professionals held at Vanderbilt University. Speaker selections have been finalized, and yes, Beej is one of them. Sessions can be found at sessions.musiccitytech.com. Tickets are still on sale, and attendees can register at completedeveloper.musiccitytech.com.
In philosophy, formal logic is the study of deduction and inference, or the steps in reasoning, through the use of formal content. Logic programming is a paradigm that is based on formal logic. Now, also known as mathematical logic, formal logic is also a subfield of mathematics. It is basically the application of philosophical logic to math. Logic is its own language with a syntax, semantics, and inference rules.
Syntax is the rules around how to build formulas, or in philosophy, the sentences that create the logic statement. This would be the language in what functions and methods are available, or the equivalent. Semantics define the meaning of the formulas, or what is created with the syntax, through logical consequences. This would be the outputs of the functions. Inference rules are rules setting how to come to conclusions. And this would be equivalent to rules governing what you can do and expect from functions and methods. This is like your invariance, covariance, contravariance, those kind of things.
Right. Logical programming is a set of logical deductions that are controlled through a flow. The logic, or what is being done, is separated from the control, or how it is being done. And this allows for interchangeable parts where the logic piece sets the result and the control piece can be changed to still produce the same result. In a paper published in Communications of ACM, Robert Kowalski said, the algorithm equals logic plus control. Well, we're going to start by defining what a horn clause is. We'll get into that in just a moment. Then we'll talk about declarative programming, or the way that logical deductions are coded. Next, we'll discuss the other piece of logic programming, the control flow. Following that, we'll go over a few concepts of logic programming and close out with a comparison of functional and logical programming paradigms.
So the first thing is the horn clause. Now, a horn clause is a way of formulating logical statements. It was named after Alfred Horn, and he was the first to recognize their significance.
Yeah, it's a clause or disjunction of literals. That's basically a set of alternatives with at most one positive literal. And then on the reverse side, a dual horn clause contains at most one negative literal. So a literal is an atomic formula that is referentially transparent, which, if you remember from the functional episode, means it is replaceable with its corresponding value.
Right. So it's almost like a constant in programming, but not quite. I guess the way that I've always thought about this is if you call a function, the result is the same every time. So you could, if it is the same every time, then you can replace that function call with its result.
So in other words, if you pass in the same values, you always get the same result, and it doesn't change the state. There's no side effects.
Right. So it's essentially something you can inline.
A definitive clause is a horn clause that has no negative literals. And we're going to get into that a little bit more when we talk about some of the concepts within logical programming. I know it's like a lot to take in. I actually wrote this piece of the outline after writing some of the other stuff, but decided to put it at the beginning because defining it here, when we get down later, you'll better understand it. What is a clause? A clause is written in sort of an if-then format, and we're not going to go down that rabbit hole because, oh my goodness, I spent a couple of hours yesterday just looking through what clauses are.
It's like trying to write one episode on date time.
Yeah.
Yeah.
We gained about 3 episode ideas out of it, though. So
yeah.
we'll get to it. Basically, it can be something like if A and B, then C.
Or it could be if not A or not B, then not C.
This will come up a lot in the control side of logic algorithms, so we're going to talk about that in just a little bit. But before we do, I want to start with the declarative side of programming. And this is in the algorithm equal logic plus control, this is the logic side. This is what states what's going to happen.
Okay.
So declarative programming is a paradigm that states the logical computation.
And the important thing here is it doesn't describe the actual flow through the computations. In other words, it's not an implementation specific.
Right. It focuses on the end result.
So the best example I can think of for this sort of headspace is SQL.
Yeah, SQL is great.
SQL written by competent SQL developers, not SQL written by somebody that likes nested cursors or something like that.
Learning about this, I was thinking of SQL, and then when I started delving into specifically the declarative programming, because like each point on here I did a deep dive on and pulled the relevant points. But when I dove into declarative programming, I think I became a better SQL developer out of this.
Yeah.
Declarative programming emphasizes what you're getting out of the function.
Not what you're putting into it.
Right. Or how you're getting it.
Yeah, which is why I brought up the SQL thing, right? Like, you get to be a lot better at SQL when you think about what you want the end result on a column to be versus what you want to do to the rows.
The how it gets there is irrelevant. And it's really interesting because one of the examples I saw, and we won't go into it too deep, but was with JavaScript. The link is in the show notes so you can follow it and find this, but it basically had imperative programming and just like, we need to do this, so we're going to do a loop and like a for loop, not even a for each, just a for loop to loop through it and get it. And then it showed the same thing with declarative, and it used .map.
Yeah, I sent you an article, I think earlier this week or last week, from Ed Charbonneau. That was that same kind of thing, and that's on the Tellert blog. And it was really a really good explanation. I sent that to a lot of people.
Yeah, I quickly glanced at it. It's on my reading list.
Yeah.
So the other important thing with declarative programming is it lacks side effects and is referentially transparent. And so my comment here is uber functional. Because like when I was writing this, my first thought was, ooh, functional.
Yeah. It was not something that sunk in for me as early as it did for you, how side effects make everything harder. Like that's not something that they beat into our heads back in the 90s. It's just, like late 2000s, you go, wait, this is really making a lot of things more and more painful. And it started getting, the cracks started showing, and then it becomes widely known that, hey, like you don't want to call a function and have it mess something up that the next time you call it, it changes the result.
Well, I think part of that is I learned very procedural languages.
Yeah.
At first, and just barely touched some C++ and learned a bit of object-oriented. And then I got out of programming, and I come back with like heavy object-oriented, and people are seeing a lot of the problems, and functional is like coming back onto the scene.
Yeah.
And so like that's probably why it came earlier for me, was because I had this weird comparison of, all right, I saw the early stages of object-oriented and how it fixed the problems of procedural. And then I come back and object-oriented has its own problems, and I'm seeing some of the solutions to that.
Yeah. Whereas I went through the entire...
So you were there through the pain where I left and came back.
Right. And I mean, like a lot of the object-oriented stuff was built around side effects. It's like I have a data object and I'm doing side effects on that thing.
Oh, yeah.
I'm passing the same reference to a function multiple times, but I don't get the same result out anymore.
Right. So by comparison, imperative programming goes through the flow. It describes the actual flow through computations and uses statements that change the program state. Imperative programming also focuses on how the result is obtained as well as what it's obtaining.
Right.
We're going to have a whole episode on the different programming paradigms. It's in the backlog. I added to it with this, so there's more to come later.
Yeah, so this had a side effect of touching our backlog.
Right. Declarative programming is an overarching term that describes several different paradigms. So it's not just its own thing, but it is actually several different programming paradigms. One of that it uses is modeling, which is a paradigm that represents physical systems in declarative code.
Right. And in this one, you use equations to declare behavior in relationships. Mathematical calculations are used to algebraically manipulate and find solutions. Languages include analytics, Modelica, and Simile, none of which I've actually used.
Yeah, I didn't think you would have, because most of these are...
They're kind of one-off, like...
They're really low-level, or they're very specific to, like, research. Like, I think Analytica is really research-heavy.
Yeah.
Constraint programming sets the relationship between variables by using constraints on the variables. So the constraints don't specify how solutions are obtained. Instead, they set the properties of the solution, stating what it's looking for by the code.
In the refinement model, variables are not initially assigned, but assumed to be anything within the range of the variable. So it's not necessarily set-based, but it's like, hey, here's your options. Mm-hmm. And then it picks the one that matches.
In the perturbation model, variables are assigned a single value, but that value can be changed. So it's mutable. Whereas with the refinement model, the variables aren't initially set, but once set, they're immutable.
Right, because it's almost. I would almost think that the refinement model that sounds a lot like massively parallel systems would be great for that. Now, another paradigm that you're going to see a lot, and all of us see a lot, is markup languages. This is your HTML, XAML, XML, those kind of things.
Mm-hmm. Now, like HTML, for example, only describes what should be on the web page. It doesn't control the flow. That's JavaScript usually.
Right,
and you do not want to put your JavaScript in line with your HTML.
Yeah, and
I've seen it. You've seen it.
Well, here's something that was weird for me too, and I think this is why I really disliked Cold Fusion, was because it was that tag-based control flow, and it was just, it felt like it should be declarative, and you'd be okay doing it declarative, but it wasn't quite.
Okay,
and like you're looking at it going, I should be in this headspace writing this code, and I can't be.
Yeah, I follow you.
And that's why it was so painful for me. That, and they had like a normal, quote, air quotes, looking, coding way of doing it, and none of the developers did it that way. Because they all did the tag-based thing. I guess that came out first.
Mm-hmm.
So yeah, just as an aside.
So speaking of control flow, that's what we're going to talk about next. And it is the order that statements or function calls are evaluated within a program. A control flow statement is one that results in a choice between multiple paths that the code could take. These are decision-making statements in your code. A block groups and defines the scope of a set of control flow statements. So if you have like an if with an else ifs, that would be a block.
Right. And that's why they talk about block scoping of variables and those kind of things.
Right.
That's where this comes from. Now, control flow statements are categorized by the effect they have on the flow through the code. So a branch is an instruction that causes the app to execute different code than the default. An unconditional branch or a jump is the continuation of flow at a different statement or place in the code.
So an unconditional branch would be a go-to, where it's like, all right, you're here in the code, you go to this other place, which I just recently learned they have go-tos in C#. I didn't know that.
They do. You can write crappy basic in any language you like.
A conditional branch executes a block of code only if a condition is met. And this includes things like your if statements, while statements, and things like that only look at the code if the condition is true. It can also be loops that execute until a condition is met.
Right. Now, subroutines, coroutines, and continuations execute a block of code and then return control of the caller. So that's the important difference between that and a jump. It's the difference between a jump and a bungee jump. It's the best way to think about that.
Yeah, this is more your function calls that call a function and then return something back.
Yeah. I do think in some of the higher level languages, some things get a little blurry. Like if you look at the syntax versus what's going on under the hood, you may see some weird things like, like for each loops, for instance. It's doing a looping construct, but the scoping jumping around might be a little bit odd. Like you may have a hard time actually pinning this to language concepts the further up you go.
And then finally, an unconditional halt stops the app from running.
Right.
And it doesn't execute any more code.
In some languages, like JavaScript, you have what are called truthy and falsy statements. Now, this is where it's not really true and it's not really false. It's like we just sort of go, it's kind of it's closer to this side than the other.
Well, the thing is, what it is the objects evaluate to true or false when they're put into a conditional.
Right, so they get cast, so give or take.
It's not the value of them, it is the object themselves that evaluates in these statements. You have to be careful not to confuse the primitive Boolean value with the value of the Boolean object.
Right.
So, for example, you could set B equal false, and then you evaluate B. So, like, if B, it will return true because it's evaluating the condition of the object, not the value of the object.
Right. And you run into the same thing in C# with nullables, right?
Yes.
Or, well, not with, like, if you had a nullable of type object and you put a Boolean in there and you're going, hey, if this is equal to null or not, that's essentially the same kind of operation. It's just more explicit in C#. So that's a little bit of, languages can burn you a little bit on some of this stuff, especially when they try to make things easier for you.
Yeah, this was something that was put in to help. And I would say probably about 75-80% of the time, it is super useful. But if you don't know that it can burn you,
Yeah.
it can burn you bad. We're talking like second, third degree.
Yeah. Or, when you get one of those files that's got hundreds of not equal statements in JavaScript, and I don't mean not equal, not equal. And you're doing, financial transactions or, major control flow stuff for that, it gets really ugly really fast. So the next thing we're going to discuss is problem solving.
At the most atomic level, as in no variables, logic programming uses backward reasoning to create an and/or tree. What this does is it creates a space for the program or app to come up with a solution. And/or trees reduce problems to conjunctions and disjunctions or of subproblems.
So it's essentially making an expression tree with a limited operator set.
Exactly.
Okay.
So I got this next statement from Wikipedia directly, and it's going to need some elaboration because it is rather wordy and rather academic. Given any node in the tree and any clause whose head matches the node, there exists a set of child nodes corresponding to the sub-goals of the body of the clause.
So in other words, if I have an expression, I can turn it into a tree.
Right.
Like, just as an aside, I really hate this kind of wording because it's like, okay, let me be mathematically correct and impenetrable. And that is one thing we decided to do from the beginning is to try to get around this kind of stuff.
The thing is, we've talked about why that is that way. And in the article I read, it went on to explain, here's the catch-all statement, and then here's the explanations. Because, you and I are both the type of people that if you just gave us the explanation, we would go, yeah, but what about this case? Or what about that case?
Right. And that's what your Wikipedia readers are going to be, right?
Yeah.
Especially on an article like that.
Mm-hmm. So in this, child nodes are grouped together by the and alternative solutions and children are grouped together by the or. So an or groups the alternative pathways. So you could do this or this. The and says, hey, these are connected to each other.
Oh, okay. So they're siblings if they're and they're cousins if they're or, if their parents are or.
Yeah.
Okay. I got you now.
Yeah.
It takes a minute to put this into English.
It really does. And, oh man, it's, like I said, this is heady. Backtracking is used within the problem solving to calculate the results, and it checks each path for true-false variables. So each statement in the pathway for if it's true or false, how it evaluates. It passes on to the next line, even if the previous line errors.
Okay.
So in backtracking, all it does is it just goes through and checks these. There are different backtracking strategies that can be used to find a solution to a given problem.
Good old Prolog uses a last in, first out strategy. That's sequential backtracking. And I did do some Prolog in school, have not done anything in production with it.
Yeah, there's not a lot of
production.
Yeah, production Prolog. There's some in some AI areas.
Right.
And in a couple of like that kind of area, but not a whole lot.
Expert system type stuff.
And you don't really see it a lot in your web apps.
Right.
Intelligent backtracking and best first are some other strategies that look at the different pathways and determine which one is the best pathway to go down. Concurrent logic programming chooses the most highly or sufficiently instantiated subgoal and goes down that pathway. So the one that is either used the most or chosen the most.
The next concept is negation as failure, or NAF. It's a non-monotonic inference rule.
Now, non-monotonic logic allows for the creation of tentative conclusions. These conclusions may be removed or changed based on further evidence. So it basically allows state change.
Yeah, and that's almost a way of shortcutting that expression tree.
Exactly. In formal logic, adding a formula to a theory will not reduce the set of consequences of that theory.
Abductive reasoning derives the most likely explanation from the known facts. This is a starting point for non-monotonic logic. More facts may change the conclusion of the abductive reasoning.
Right. So abductive reasoning is a good starting point. It's a good place to begin of, all right, what's the most likely explanation based on the facts?
Yeah. And I guess this is more useful when data is still coming in. to try to short circuit the decision making process, at least for temporary purposes. So this isn't quite like short circuiting an if or a and statement or something, going, okay, I'm not even going to evaluate the second one if the first one's false. This is more like, I don't know what the second one is yet, but the first one, I have part of it and it looks like it may be false.
Right.
That kind of process.
Yeah. And it is that.
It's basically stereotyping.
Kind of, in a way, yeah.
Yeah.
It's looking at, all right, there are a million possible paths to go down. Based on the information we have, we can rule out 900,000 of those paths. So now we only have to evaluate 100,000 pathways. And then you do that, and then they do it again, and it goes, all right, we've got 100,000 pathways we could go down, and we've got some more data in that we can rule out 90,000. So now we're down to 10,000.
Yeah. And then you can always switch.
Right.
To something else. Like it's a way of culling the potential data set enough where you can actually deal with the rest of it.
Exactly. Negation as failure is used to figure out what something, like a variable, parameter, or function, cannot have as a value by the failure to get that thing. So not X from the failure to derive X. So you know what X is not based on the failure to get X back. This doesn't mean the logical negative of X as a negative X. It means not X. So I'll keep going and it'll make more sense in just a moment. In logic, it applies by looking at the result of a function and applying control logic if it is negative. So, for example, if we're looking at what I can eat, we have a function that evaluates what Beej can eat. We go, is it edible? And then, is it not has onions?
Right.
Because if it's edible, then I can eat it. That's true. But also, it has to not have onions.
Well, this actually kind of works out with the non-monotonic logic as well, right? Because you could say, hey, it has onions, so I can't eat it. But you go a little further down, you go, hey, it's got a crap ton of garlic. I can't eat that either. Because it's a whole sulfur thing, right? As you get more information,
exactly.
You evaluate it.
That's the way that flow goes.
Yeah.
This is used in a conditional to say branch if this is not the case. So, like I said, if it doesn't have onions, you go down this pathway. If it does, you stop.
Right.
Because I can't eat it.
Yeah, you'll see this a lot in expert system type setups, I think. Because I seem to remember doing some of this kind of stuff in Prolog. Like if you're classifying things, right? Mm-hmm. You go, okay, here, I've got a thing that's coming in. Okay, well, what's it doing? Well, it's walking towards me. It's probably not a mineral.
Yeah.
On average, not a mineral.
Yeah, I had not thought about that, but this is very much like, it's like playing 20 questions, where you narrow it down. Like, you start off with an infinite number of possibilities, and you continue asking questions to narrow that field down. And that's how this negation as failure works.
Right. And so this is really a mathematical formalism around the way we tend to classify things as human beings anyway. Okay, so now that we've discussed both functional and logical, let's talk about, the differences here.
Yeah, we've had an episode on functional, and we just went through some of the logical concepts and the basics of understanding logical programming. So first off, both are declarative paradigms with a relation to lambda calculus.
Yeah, which we will not be getting into extensively here, because that's a whole nother Wikipedia wormhole purgatory twitching dumpster fire journey.
I don't know that we'll ever do an episode on lambda calculus.
Yeah, it'll be a twitching dumpster fire if we do.
And if someone, the only way we'll do this is if someone requests it.
Yeah.
Lambda calculus uses mathematical logic to express its computations.
Right. So functional programming is heavily based around lambda calculus.
Yeah, I mean, it came out of lambda calculus as an application to programming.
Right.
So we're going to go through a few of the upsides and the downsides of each and kind of compare them to one another. Logical programming has a few things better than functional. And this is all from an article on academia.edu, which I will link to in the show notes.
And the first one is that it is easier to maintain, as a subjective measure. It's probably going to be easier for more people to comprehend what's going on in the program.
Yeah, it is basically a set of if and while and loops with very declarative, all right, if this is the case, this is the thing. If this is the case, this is the thing.
Right.
It's very easy to, once you understand the basics of programming and how the computer thinks, you can then read through that and understand that very easily. Whereas with functional, it's not as easy to do that because it is call this function or call that function.
Right. And I think the other thing with functional too is functional is a lot easier to have really beautiful programs in. Like where you look at it and you go, wow, that's eloquent. I wouldn't have thought of that. Not necessarily 100% true, but just a subjective measure. Now, logical programs have fewer errors compared to other traditional languages. Part of that kind of, from the previous discussion, taking an error, getting an error state and going, okay, yeah, this is false.
Mm-hmm.
That's why. It's not that maybe not so much as not having errors as not hanging on to them.
Yeah, it handles errors differently.
Yeah.
So one pathway errors, it goes down a different pathway.
Right.
So you get to the same result. And so that is how that works.
Well, it's sort of like, it's almost like you could look at evolution as being a similar type thing, right? Like, okay, yeah, there's an error over here. This one died. Well, some other branch of the family is going to make it. And so it's a different worldview because we, as software developers, we tend to treat our functions as precious. And so, like, if it went wrong, we want to know that this one went wrong. In other words, our functions are pets, whereas in logical programming, our functions are cattle.
We'll say the same with functional, though, in that aspect.
Yes.
Functional does treat the functions as cattle. You can interchange them, and it doesn't matter, and it's only used for what it's used for. Compared to functional, though, it does have fewer errors because it has multiple pathways. And so instead of, if this is true and that true errors, it throws an error. It goes, if this is true and it errors, it goes, all right, that's false, move to the next one.
Yeah.
So it handles errors inherently. Whereas with with a lot of object-oriented languages and the functional stuff that I know, you have to explicitly handle those errors.
Because otherwise it's not expected, and that means the program is malfunctioning.
Right.
And I think that's a big deal here as far as making this work better with the real world, honestly, because the rest of the world goes on if there is an error.
Mm-hmm. Finally, logical programming is very good at expressing complex ideas in straightforward terms. It boils down to if-then statements. So it's if this and this or this and this are true, then do the thing. Or you could throw an else if. So it's like, if this and this are true, do the thing. Else, if this and this are true, do the thing.
Right. And so that makes that approach probably a little bit easier for laymen as well, right? Which is the big deal. Now, not to be outdone, functional in turn has got some advantages over logical. The lack of side effects makes understanding functionality easier.
Right. Now, we talked about the referential transparency in part of logical, so I want to address this so no one goes, but you already said logical doesn't have side effects. No, the declarative side of logical doesn't have side effects. The control side can, and in some cases does have side effects.
Right, like a for loop increments a variable. Right? Like it's got to know when it's done. So it's it's continually comparing a variable to some value. So there are going to be side effects, especially if you're counting on that variable for something else.
Yeah, and so the declarative side is the part that doesn't have side effects. The control side of logical does.
Right.
Whereas pure functional, I should say, does not have side effects. Right. You don't have void functions.
Right.
Everything has an input and an output in functional, and it is you do this specific thing and get this out of it.
Right. Well, it's like a mathematical function.
Yeah.
It has to return something. It doesn't go sub without return, as it were. Now, in functional, the environment is protected from changes in state.
Yeah, and this has to do basically with the same thing, the lack of side effects. Whereas in logical programming, in the control flow part of logical programming, you could change the state. And you could have side effects that change state that affect the declarative side of things. So like the declarative side of logical isn't going to have these state changes, but the control flow could change the state, and that state change affects the declarative. Whereas with functional, you don't have that at all. There are no state changes in pure functional.
Right. And that makes rapid prototyping a lot more straightforward in functional, because you don't have to worry about, well, what if this changes while I'm using it? It's especially nice with multi-threading and those kind of things, like, which is kind of the world we're starting to emerge. Moore's law has, I don't know that it's completely petered out yet, but we're sort of discovering that, hey, we can branch out to more processing power versus speeding up the current processors we have. Like, we've hit a wall on that as far as what's reasonable compared to what we can do with just more.
Well, I think Moore's law is still in effect. It's just going a different direction now.
Yeah. Well, it's like you get, you have one dude can build a house in a month. You can only make that dude so much faster or stronger. Whereas if you get 40 other dudes in there, that house gets built faster up to some other point.
Yeah. At some point, you still have, all right, well, they can only build at a certain capacity, but yeah. Right.
You hit a limit of physics. This is just a different way of interacting with it. So that's kind of the way I've thought about this.
Now, not everything in logical programming is perfect, and it does have some disadvantages. It's not widely used. We talked about that. Not very popular. So finding help can be difficult, though these days that doesn't seem to be as much of the case as you're getting more neural networks and more AI.
Yeah. And I think the other thing, too, is the internet has grown a lot, right? Like when I started doing software development, there were different groups you could go to. Like there was, you get on Free Agent, right? And you would go and find like a Visual Basic group. And there might be, 10, 12 people on there. There might be one that gets on today because everybody had dial up and not everybody got online every day. But now, if you can have a group of, 15 people across the planet, you can probably find somebody on at any given hour that can help you. Mm-hmm. So I would say that this is maybe not as bad as it used to be. That said, compared to how many people you can get to help you with JavaScript.
Yeah.
Like JavaScript has really, really leveraged a lot more comparative advantage there.
Right. It's not like you can jump on Stack Overflow and have a John Skeet help you out with this.
Yeah, although John Skeet probably does know how to do this.
Yeah, I would not put it past him.
And we didn't confirm that he hasn't answered 5,000 questions on this because we can't really look through all the questions he's answered. Because, again, this goes back to the whole state change. The state changed while you're looking at it.
Yeah. And honestly, if John Skeet, if you're listening to this episode, dude, why are you listening to us? But second, hit us up. We'll definitely have you on as a guest. So that's awesome. What I'm getting at is there's not as many resources available for helping you solve problems.
Right.
With this as there are with, say, functional, which is a lot more popular. It is really growing. You have communities built around it. And I know there are communities around logical programming, but they're just not as large and not as deep.
Well, and they're also, I think the other thing that functional has as an advantage is a lot of languages are trending functional, whereas there's not many that seem to be trending logical. And as a result, you got a lot of people kind of dipping their toes in that pool.
Though I will tell you, with all of the AI and stuff like that becoming hot topics, who knows? I may predict an upswing of logical programming languages at our next predictions.
Yeah, and I mean, the other thing is there may be an uptick in illogical programming languages. There's 2 or 3 of them I can think of right now.
There already is an uptick in illogical programming languages.
Well, there's JavaScript with this.
Oh yeah. So also, the predicates are difficult to read and understand in logical programming. Now, we talked about how it's easier to maintain and easier to learn if you're getting started and you're looking at some more complex code.
Yeah, those predicates can get really, really long, right? Especially if you're not limiting the number of nodes across.
Right.
Like if you're looking at it as an expression tree, like the breadth of that tree can be really, really wide.
It can. And that's where it gets complicated. It can just be overwhelming almost, especially for newbies at it who haven't garnered the understanding of how to look at that without being overwhelmed.
Right. You need to be able to take Leviticus and reduce it to the 10 Commandments. Effectively, right? Like that's what you're doing, give or take, so that you can get your head around it.
Not to throw to a Judeo-Christian.
Well, I mean, it's the best paradigm I could think of, right? Like,
well, it
because
works.
Leviticus is a whole lot of that, like deeply nested. You're like, man,
it is, yeah. Now that we've talked about logical, functional programming has its own disadvantages as well. That things that logical programming has. First off, it can have a negative impact on debugging.
Right, because if you can't screw around with state changes, what do? I mean, there's a whole slice of debugging that you don't have anymore.
It throws a wrench in that, especially if you're used to object-oriented debugging. Now, I would assume that if you have come up in a completely functional language and are used to functional debugging, it's different because you didn't know there are things missing.
I think the other thing, too, is functional probably does not, on average, rely as much on debugging as object-oriented. I mean, part of the reason we need a debugger is because we're screwing around with state. If it's just a projection from a chunk of data, like how much debugging do you really have to do? It's like the answer's right or wrong. How did it get that way?
Yeah, that makes sense. Also, functional programming may not match the way that the hardware works.
Yeah, so like if you're calling a database, you're writing to the database, you're creating a side effect. Honestly, one thing with databases is like, let's say you have a trigger on select that writes to another table. Your read just altered data. Now, it may not alter the data you're touching, but at what point do you account for that in functional? I don't know personally, like how that headspace works, because that's not the way I think about things.
That's a point I had not thought about with functional. I was just thinking on the write to the database as being a side effect.
Yeah.
Because, object-oriented, it's all about, all right, manipulate the side effects.
Right.
And functional is, there are no side effects. You do things with a purpose or you don't do them at all.
Right.
And so, because that was one of the biggest things when we had our functional episode that threw me, that I'm like, I want to get someone in here that really knows this, that can explain to me, all right, how do you deal with database interactions? Or even other APIs? How do you talk to other programs like that? That is something that is one of the disadvantages of functional, is that because of, and it may just be my own paradigm of object-oriented, that I don't understand how that works as well.
Yeah, I mean, I think we're kind of in one of those situations where, the bird is looking down at the fish and wondering how it doesn't drown. Mm-hmm. And it's a different headspace.
It really is. Speaking of a different headspace, the last disadvantage is it can be more difficult to learn by those starting out than other paradigms. It's like where I work, there's another junior developer that we've had several conversations, and he cannot stand functional. He doesn't like how terse a lot of the functional languages are. And I follow that, but he is a huge fan of object-oriented programming. He's also the type that would rather, write out a for loop than do a lambda statement. Just because he's like, well, it's easier to read. I'm like, yeah, but this optimizes.
No, it isn't.
Yeah, well, that's what I said. I'm like, once you get used to this, it's easier to read this, but, yeah. And that's not a problem. It's his background and what he's used to.
Right. Because, I mean, I remember when I first started screwing around with lambda functions, I felt the same way.
Oh, me too. I was confused by him, but I wanted to learn him because I'm like, that's a more efficient, better way of doing it.
That dude typed less.
Yeah.
That was what my main motivation was. His fingers moved less to do the same thing I just did.
Oh, yeah. I completely get that. So, guys, this has been a rather heady episode with a lot of Wikipedia and Google rabbit trails along the way. We've only just hit the surface of all that is involved in logic programming. Its basis in mathematics can help us to better understand the underlying functionality of the code we are writing. Also, reviewing common concepts like control flow in terms of something new helps even the most senior developers better appreciate and understand what they're writing. If you want to know more about logical programming or any of the concepts we've talked about here in this episode, check out the links in the show notes. That pretty much wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, so I want to point something out that kind of came up in this episode as far as, I wouldn't call it lazy evaluation, but it's sort of a way to go through life that I think is very useful. And that is being able to react to incomplete data. One thing I see a lot of programmers really, really struggle with, a lot of people that are in really technical fields, is how do you deal with a situation where you don't have all the pieces? And I think this is something that logical programming really brings to the fore, in that you can essentially branch based on the data you have until you get more information. And this sort of lazy evaluation is a pretty reasonable way to go through life. For instance, you start turning down a street, looks pretty rough. Maybe you ought to turn around instead of going, well, I don't completely know if this street's rough. Well, that's immaterial. You may get robbed. Now, again, that doesn't mean that you do the whole stereotyping thing, but be aware that sometimes there are shortcuts that you should at least consider until other information becomes available. And I find this really apparent, especially in things like giving estimations for software projects. Like, I can't count how many projects I've been on where somebody said, well, how long is that going to take? And they go, well, we don't know these other pieces of information. Instead of going, hey, we don't know these other pieces, go, it's going to be this unless something else comes up, and maybe pad it a little bit for that risk. In other words, be able to learn to function without all the information, because you're never going to have all the information. Like, you can sit there and, like, if you start thinking about your personal relationships and those kind of things, if you don't have all the pieces, that's still okay. So I just want to throw that out there as something to kind of bake your noodle a little bit and try to get away from the programmer think on this kind of stuff, because it is extremely valuable and it'll still help you in the programming. So that's all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.